All right, welcome back. We are week 2 of Game 3001 and the winter 2021 semester, and it's part 2 of our broadcast. Earlier today, we did a lecture on steering behaviors and a little bit of kinematic movement, and now we're going to get into some of the lab on how to make things work. Okay, let's get to it. So, I'm going to start off with our project from last day. So if we look at our desktop, and if we look at George Brown 3001, so that's this one right here. We had a lab 1B that I was running last week. Let's use that one. So I'm going to double click on template.sln to start the application. I asked you guys if, as homework, if you could do a couple things. One thing was, can you create a game object for the project? Can you do that? And some of the stuff that I got earlier in the first session was, I forgot or whatever. Again, what I want to remind you is that one of the things that you're going to have to be doing is manipulating the template for your assignment number 1. So please don't, not do your homework. I think it's important. One thing I've done is from this morning's lecture, I've embedded the 2 overloaded functions that we created together in the lecture. So I have my lerp function that also takes a vec2. And I also have a random range function right here that also takes a vec2 inside of my utility util.h. Okay, so that's something that I have in here that I put in. What I want to do now is, before we get going on this, I want to talk about Git and GitHub a little bit. So for those people who are watching live on YouTube, this is for you. And the idea is to talk about Git and GitHub. All right, let's do it. So what is Git and GitHub? And I know that you guys had a bit of a primer on Git and GitHub during your game fundamentals. I think that's kind of an important thing that you guys are doing. And we're going to continue to work with game fundamentals, the stuff that you learned in game fundamentals this semester. And one of the things that we're going to tie into this semester is, this idea of what version control is. So notice on the bottom right of my screen here in my template, I have this thing that says add source control, add to source control. So again, if I right click on my solution, there are a number of options. One of them is retarget solution. Another one is create Git repository. Okay, and there's a lot of other things. What I want to do is, you may see something different than create Git repository if you haven't initialized Git repository in the first place. For me, I see create Git repository, but you can also choose add to source control. Let's choose this option, right? And I'll explain the process that I'm going to go through in a second. So let's click add to source control. It asks me for Git. That's my default. I'm going to click on Git. And what this has done right now is my whole project, it's taken a snapshot of my project and added it to source control. That's what it's done. Okay, and I have additional pieces here that we're going to talk about in a second. So what is source control? Let's do a little bit of drawing. Actually, I have it right here. And let's minimize this stuff. So the way it works is this: you have some local files, and in your local files, what you have is a bunch of files that you share, or you have on your system. And one of the challenges is, what happens if your system dies? So what happens, as an example, if something goes wrong with your computer, God forbid, and then you lose your files. You've been working on some assignment, and then it's gone. You lose your files. That'd be bad. So what people do to avoid this is they use Google Drive. They take your files, and let's say you have a number of files here that you have for your system, and you take them and you put them on Google Drive. right? And the problem with that is that you can't really keep track of what's in the project folder. Some people, what they do is when it comes to beyond backup, that's okay for a backup. But the problem with that is, where is it in Google Drive? They lose it. What's in it? What's in your project? Are you doing something with it that is specific, as an example, that makes sense to you, and so on? So that's an issue, right? Like, for example, how do you keep track of what features you added into that particular project? Or is it, do you put on, my project V1, my project V2, my project V3, my project V4, and so on. And you have a bunch of, versions of your project, and you in your mind know what it is. But what happens when you come back after a year? How do you know which project is what, kind of thing? So, putting something on Google Drive or Dropbox or OneDrive is not a great example of how you do version control. So one of the first reasons why I use version controlling is backup. We want to make a backup of our files so we don't have that issue where our laptop burns, all right, or something happens to it. Our desktop that we have at home, it doesn't work anymore and we lose our files. The next thing is, from a revision control perspective, and where I say feature mapping is, let's say I add features, or I have some kind of break fix that I put into play. I want to be able to track that, and not just with a V1, V2, V3, and so on, but with other things that are happening. I can track it, with more detail, is what I'm saying. And it doesn't matter whether it's now or whether it's 5 years from now. I can look back at the project and say, okay, I see what's in there, as an example. The other one is, which we haven't talked about, is collaboration. Sometimes we want to share our work with other people. In fact, most of the time we don't work alone, we work with others. On your local machine, this doesn't work very good, because you really can't share your files with other people unless you do things like, again, sharing on Google Drive. You pass it around on OneDrive or something like that. But again, you'd have to, every time you make a change, you're gonna have to send them an email or some kind of direct message saying, hey, I got an update to my files, check it out. I put another version on Google Drive. And that doesn't make any sense. So we want to keep a centralized location for all of our files, and we want to make it so that it's not on our system and that it's more robust than Google Drive or OneDrive or Dropbox. And we use a service like GitHub, and GitHub is only one of several cloud services that allow us to host our repositories. So we have our local files and folders, and up here we have a container, which is an empty container, which is also called a repository. The repository is just a fancy term for an empty container where our files kind of live online. One thing to note is, in our repository online, we don't have direct file access. And what I mean by that is, we can't manipulate files as if they're in a folder, or something like that. It's more that this is a mirror of what we have in our latest snapshot. So what happens is, as an example, let's suppose that I took a snapshot, and there's different words for the snapshot that we're going to use, but let's suppose we took a snapshot of our files, and the snapshot of our files we put up on GitHub. This snapshot is it's exactly the same, a clone, if you will, of what we have locally, and it's up on GitHub. Well, there's a couple things it handles. One, it kind of satisfies the backup requirement. Again, these are the main reasons that I can think of. The second thing it does, it takes care of revision control, because when we put it up to GitHub, we've also created a named snapshot, and the named snapshot is usually a commit. That's what we call it. The commit is a named snapshot of my files in its current state, whatever the current state of the files are, right? And the named snapshot, that name is really important, because it kind of indicates to people who are sharing the files with us what they intend, what the files have in them, and what is our project, as an example. So that is something that we can see as well. So our snapshot is here, and then we put kind of a clone of what our files are up online. So it satisfies any kind of feature we add in. We can name it with the commit, and it satisfies the revision control, feature mapping, and debugging feature. or aspect. The next part is collaboration. If it's up on GitHub or another cloud service and it's public, there's different kinds of repositories. We can have public repositories, right? And so we can have that. And we also can have private repositories. So that's something we can also do, private repositories. And our private repositories, a lot of times is we have them as, we have our private repositories so that maybe we're working on a game, and welcome for people who are coming in late. We're working on a game, or we're working on a feature set or something else, and we want to keep it private, or we want to have images that we don't want to share in the public domain, as an example. So we have a private repository for those things, or we might have secret API keys or something like that. We want to keep that in a private repository. But public repositories are great to share our work, especially when it comes to an interview, or if we want to share with the community or other people. So public. We can also share private repositories with certain users. We have that ability. But basically what we can do is we can control who can see our files and our folders and how we keep track of them. So first, everything starts, and again, for when we're starting off, I'm just talking about Git and GitHub here. So locally is where we want to start first. First, we initialize our repository. Whenever we initialize a repository in the background, no matter what kind of tool you're using, whether you're using, as an example, something like Gitkraken or SourceTree or GitHub Desktop or whatever you're going to use, right? In the background, whenever you initialize a repository, and we just did it with Visual Studio, it creates this hidden .git folder. And this is where your repository is being tracked, all right, locally. So you have a local repo. So local files, also you have a local repo, right? And the local repository is something that is, again, it's kind of trapped in your machine. It's good for keeping track of changes, and eventually, hopefully, you're going to push the local repo to the online repository. So this is like an online, repository. There's other options, by the way, too. If you don't want to use an online repository and you want a private server, you can do that too. Larger institutions use private GitHub servers or GitLab servers that they set up. And they also use other version control systems like Perforce, where they have more control about access to individual files, not just the actual folder itself. So that's kind of something that they use. So again, whenever we push, we can do a git init in the background. We create a local repo, and then what we want to do is we want to add files to our repository. And there's a couple stages of that. The way we would do that is we have a group of files that we select. Again, so we select some files to add, right? That's what we do. And we use the git add command, right? That's what we do. So we select some files to add with git add. When we do that, what it does is it sends these files that we select to something called the staging area. All right, so the staging area, again, is just another receptacle or container, right? That is a temporary spot where your files are being stored, like just the files that are, again, marked for, for commit. So staging. And the staging area is created as soon as you use the git add command. Typically what we do is we do git add dot if we want to add all of our files. Dot, if we add a dot here, then that means add everything. So add all files, right? We can also specify individual files. Let me just make that smaller. So dot basically adds all files. We can also add a specific file, git add readme.md. Only that one file gets added to the staging area. And the staging area is like saying, hey, these are the files I flagged that I want to, package in my commit. And my commit is just a snapshot of, again, my current files. So git add dot. Then we do a git commit. And the message, the way it works for git commit is it's git commit minus m for message, and then the friendly message for your, your snapshot message for snapshot, whatever that is that you're going to say. Usually it's something like, and it's related to a feature, adding a feature or whatever you want to add. A lot of times what you're doing with this, the first time you do this, it's usually initial commit or first commit. That's what we do, kind of add it in to GitHub. And then what we want to do is we want to set up this thing called a remote. The remote is a named connection, connection to GitHub or to whatever service you want. So an example would be the way that line looks is something like this: git remote add. We name the remote something like origin. That's a typical convention. And then plus the path of the remote, whatever that is. For example, https://github.com//your account, whatever that your account name is, / your repo.git. That is the full path, if you will, of a typical remote. Okay, so that is the remote. That's what it looks like. Okay, and typically what we have is the origin remote. That's what this is. It's called the origin remote. Again, you can name this remote anything you want. If you want to call it the GitHub remote, you can do that. Okay, again, what we're talking about is convention. Conventionally, it's called origin. Okay. When you push, it's not enough just to push. You have to specify where for the first time. You have to maybe say something like git push. So again, git is the command, how we start the commands. Git push, and then where across the origin remote into the main branch, as an example. So this is where am I pushing across and which branch am I pushing into. And from a branch perspective, let's talk about this for a second. So here's the way Git and GitHub works. We push it across this direction up towards GitHub, the origin remote, and into the main branch. And a branch basically is one or more commits. That's what it is, one or more snapshots that follow a feature set or a development continuity. So we kind of start off with the first commit, and we have the second commit, third commit, and then we're like, okay, I want to add a new feature to my main branch. This is the main branch. I want to add a new feature, so I make a new branch, a feature branch, call it whatever you like. Maybe I want to add a feature called the player movement branch, and then I add my player movement over a couple of commits, let's say, and then I merge those two commits back into the master branch or the main branch, and now all of this is contained within this last commit. Every commit includes, pretty much for the most part, all of the previous commits, right? So it's kind of a recursive way of looking at your development history. So we take this whole thing, we push it to the main branch, right? When we do a git push. And if I make a change, let's say as an example, or somebody else I'm working with makes a change and they push it to the repository, a lot of times what I want to do is I want to pull, right? I want to pull those changes back into my local repo so I'm in sync, I'm in synchrony with what's happening up online. So what I want is I want to do a git pull from my, I can specify a remote. Or it will accept the default remote that I've named as the place where I'm pulling from. Okay, so again, git pull is the command to pull, which means it's like a download, and it goes in this direction, it goes towards my local repository. Git pull, git push. When you're working with Git, what you want to do is continuously do a new commit. So you do some files, you add some additional features or whatever, and then what you want to do is issue a git add dot. I git commit -m and added some feature, whatever you did, right? And then a git push, origin main, or just a git push might be sufficient. Okay, depends on how you set your system up. So this is kind of stuff that happens over and over again. This is kind of repeated. As an example, you keep on repeating this step over and over again. So this is repeated. Right? Okay. And that's really, kind of Git and GitHub in a nutshell. Git is something that you run locally. You set up your local repository. GitHub is platform as a service somewhere in the cloud, and you push, from your local repository across the origin remote into your GitHub repository that you set up ahead of time, or at the same time. And then when you need something to be done, you pull, or if someone adds something to the repository online or through their access, you can pull it back and update your local repo. As you work, you want to do a git add dot or specify which files you want to add, and then name your snapshots over and over again as you continuously add new features. Okay. So we've kind of done that already with Visual Studio here, and I'm working with, again, files that we're working with, which is for your class, it's GAME3001, Winter 2021, Lab 1B. And I've kind of launched it here in Visual Studio, and I've added solution to source control like I showed you, and it took me to this Team Explorer tab. If you don't have access to the Team Explorer tab, just go to View and go to Team Explorer, and that'll bring up the Team Explorer tab. But it also gave me this view for the first time, and it seems that I have this thing that says Publish to GitHub. You may or may not have this item here, and the reason why you may not is if you haven't added in your GitHub extension. Okay, and the way to get that is if you go to Extensions, and if you go to Manage Extensions, and you can see all of the installed extensions. These are all the installed extensions. One of them is GitHub extension for Visual Studio. If you don't have this, you can go to Online, and then you can search for Git. And if you do that, you'll see that there are different extensions. The one you want is this one, GitHub extension for Visual Studio. You can see that I have a check mark next to it, which means I've already downloaded it, or it was installed when I installed Visual Studio 2019. If it wasn't installed, you'd see a download button, similar to this, download button. If you see the download button, click onto it, download it. It'll take some time to do it. And then what you'll have to do is restart Visual Studio and then come back to the Team Explorer tab. When you come back to the Team Explorer tab, you should see this Publish to GitHub extension now. All right. Otherwise, you'll only see Azure and something like Publish Git Repo, something like that. Maybe you only see these two. But if you see this one, that means you've got the GitHub extension and you've got additional tool sets to help you do Git and GitHub right from Visual Studio with no additional tools and no command line, which is, I think, what we want. All right, so this is cool. So we've got this. I want to click on, go to Home, and I want to go to Changes. And typically what we see in Changes is any changes, file changes we see here will be listed. You can add the files to the staging area if there are any unstaged files, and then add a commit message, commit all. When you're done committing, you can go to Home, you can go to Sync, and then you can push. Now, I haven't established a remote. Remember, we talked about setting up a remote, usually called origin, and some kind of path to my repository. Let's do that now in Visual Studio. So in Visual Studio, I want to go to Publish to GitHub. If you set up Visual Studio for the first time, it'll ask you to give permission to GitHub to add to your account. It'll ask all kinds of stuff. And if you've given permission to GitHub and you've approved access, then you'll be allowed to see all of your accounts. I have more than one. I'm going to choose George Brown. And I'm going to create a new repository here, which is GAME3001, Winter 2021, Lab 1B. You may also have to, before I do this, if you go to Home and if you go to Settings, this is in the Team Explorer tab. And if you go to Global Settings, I'm not going to go there right now, but if you go to Global Settings, in Global Settings, it'll show you your email address related to GitHub and some other options. You must put in at least your email address and your name in there. Otherwise, from a global perspective, it won't know who you are and it won't allow you to push to GitHub. When you have that in there, and if I go to Home, and if I go to Sync, and if I go to Publish to GitHub, and I choose George Brown, you would choose your own account name. I can flag it as private if I want, or not. And right now I'm making it public. I can click Publish. And what this is going to do is it's going to go up to GitHub with my permission. So it's going to ask you to log in for the first time if you've never done this before. put your credentials in. It'll remember your credentials and it'll hold your password in a secure location so no one can spot what it is. As an example, even if someone uses your Visual Studio, right? And then it'll allow you to push up online. And what you will see now, if I go up online and if I go to GitHub, so let's go to GitHub and let's take a look. You'll see that I have, if everything went well, then I will have Lab 1B up there. Here's Lab 1B. And Lab 1B, it has a bit of a README that talks about the STL engine that you guys are using, and it just added all the project files. Microsoft did this for you. What I've done is I've included a default git ignore file, which allows us to basically download our project with all the DLLs intact, so you can always download this thing and run it, and it works well. Okay, so that's what this does. I want to change my README file because this doesn't really reflect. It's not really STL engine necessarily that I'm using. I'm using it for my assignment. I'm making maybe I'm using doing assignment 1. I'm acting like if I was a student, this is what I would do. So what we want to do is for assignment 1, I want to go into Solution Explorer and let's just do the lab part. So for the lab for today, which is going to be due Friday for you, you can go into the docs filter and into readme.md. Let's change something. So let's see how this works. So if I remove all this stuff from readme.md and put in something like GAME3001 in the winter 2021 semester, and it is, lab 1, which is what we're doing here. I can specify that this is a demo project for lab 1, right? As an example, I can save that. And when I save it, if I go back to Team Explorer and if I go to Home and I go to Changes, here's Changes, then you can see that indeed it's marked readme.md as an update. Let's see how this works. So if I have a change, I can click plus, which adds everything to the staging area here. And then I can say something like added or updated readme file, readme.md file. That's what I've done. So I'm going to commit staged, okay, and then I'm going to go home, and I'm going to go sync and push, and then that is the workflow, right? So I can push everything up to GitHub, and if you notice now, once it's done, I can go back up online, and if I refresh, you can see that README file has been changed, right? And I have a second commit, and you can actually look at the commits on GitHub. You can see that I have added my project files 24 minutes ago, and I added my README file 24 seconds ago, right? Just by luck. So that's how it goes. And the date that this was all done, who did it, and so on. Okay. So pretty straightforward process. And if you look at the Solution Explorer here again, so here's my Solution Explorer. You can see that everything is updated. Okay, I'm ready to work on this next piece. And what I want to do is, this is the first part. The first part was I wanted to set up Git and explain how Git and GitHub works for you guys so you can use it for your projects as well as for your assignment if you wish. It's going to be a requirement that you're going to use later on. But this is basically something that you need to learn how to use this semester and ongoing. Okay. So I asked you guys to put together a game object, and we have several game objects here, but I want to create a brand new one. And what I've gone ahead and done is I've downloaded a new Spaceship Texture. So if you look online on George Brown, there is a new texture down here called Spaceship Texture, Spaceship.png, that I've kind of quickly created from a texture that I found online. I cleaned it up a little bit, and this will allow you to put things together, to use this texture going forward. If you want to do what I'm doing, going forward. Okay, so this is what this is, Spaceship.png. Let's use this Spaceship.png by downloading it. So I'm going to kind of, I've already downloaded it. And I'm just going to kind of pull it up in my downloads folder. So I'm going to bring it up in my downloads folder, and I've got my spaceship.png file. Here it is. And what I want to do is I want to take my spaceship.png file, which is 71 by 52 and 64 kilobytes. And I'm going to put it inside of my Lab 1B assets folder textures. That's where it's going to go. There's already several that I've got in here, right? That I'm using. So what I can do is I can copy paste. So copy, Control C, and go here and Control V. And you can now see that I have my funny little ship that I found online. There's my funny little ship right here that I've copied and pasted inside of the textures folder of my assets folder of my Lab 1B. Welcome, Christiana. All right, so that is where it is. So spaceship.png. Okay. So again, for those people coming in late, all I'm doing is I've downloaded a spaceship texture. So spaceship.png, I put it up on GitHub, right? And I've downloaded it now, and I've put it, I've kind of inserted it into my project inside the assets textures file folder. There it is. Not the prettiest ship, but it's something we can play with, something we can experiment with as we go forward. I want to make a brand new game object out of this thing, right? So let's do that. So again, I'm going to bring up Visual Studio, and let's think about how to make this project. So here under Game Objects, the filter, I have several examples. Let's make a brand new one. I'm going to right click on my game objects. I'm going to add a new item. And again, Christiana, if you're joining me, all I'm doing is I brought up last week's lab, Lab 1B, and I'm continuing from that point. You can also download the current version that's on if you want to follow along with me up on GitHub. So if you go to github.com / George Brown College, there is a lab GAME3001 Winter 2021 Lab 1B that you can download from here, and then you can continue from where I'm at right now. All right, so that's great. Let's go back to this. So I want to add a new two parts, the .h and a .cpp, and I want to add it into the, just a second. I want to add it into the game objects filter, and I want to do that, I want to do that through, there we go, lost connection there for a second. I want to do that through this little dialog box, right? So the way to do that, there's also another option. So if I cancel this and if I go back to the filter, I can also add a class. I don't recommend this for our project. I think you should just do add new item. Add new item allows me to add a .h or a .cpp. Let's add a .h. We'll call that spaceship .h. Okay, and it can't go in the template. It has to go in the src folder. So I'm going to browse there, browse into the src folder. This is where I have, that's where the source files are for our project, which I talked about before, not the template. If you add it into the wrong spot, like if you add that into the template by accident or something, then it won't connect properly to your project. All right, so I'm going to add a .h again to my spaceship, or spaceship.h to the project. That's what I'm doing, right? So that's okay. And I'm going to click add. And what this is going to do is it's going to add a template for my project that looks like this. Let's do it again. So I'm going to add a new one. So I'm going to add a new item, and it's going to be a CPP version of the same thing. So I'm going to say that, okay, this is going to be spaceship.cpp. Again, this is something that you had been tasked to do last week, and most of you had not got this complete. So this is where my spaceship.cpp has been added in. I want to immediately include the spaceship.h. There it is, spaceship.h. And what this does for me is it allows me to connect or link those two files together, where the .h is the interface and the .cpp is the implementation. All right, let's get back to this. So once I've got that, we've got a pragma once, but pragma once is like a guard, an include guard is what this is, right? And what the include guard is it stops us from including the file or doing a cyclical reference with this file or more than once. We don't want to do that. So what we want to do instead is we want to use another directive, if not defined, and we want to say spaceship. Then we want to define spaceship, okay, and end if. And we want to say that we defined spaceship. This is just a convention for how this is being done. But more or less, what this does is says, okay, if this little macro spaceship hasn't been created, as an example, if it's not created, then define it. And once it's been defined, then it'll skip this the next time you come to this thing. It'll skip this whole header, and it's kind of a directive for compilation purposes, so that we don't include the header twice. And it's cross-platform, so it should work on Linux and Mac, or other compilers. Actually, is another way of saying it as well. So now we want to, kind of declare a class. The class is going to become called Spaceship. It's going to inherit from a public display object. Okay, that's what we want, public display object. It asks us, do we want to include, do a new include? And the answer is, yeah, we do. We want to include display object.h. Right, there it is. And that was our little resharper C++ saying, hey, by the way, you may want to include display object.h because you're inheriting from it. The colon means inherit from, public is required, and display object is the superclass. What I want to do now is include all of the default methods that come with display object. So in order for us to do that, we're going to click on the little hammer after I click on Spaceship. The little hammer says generate missing members. And it says we have draw, update, and clean. Let's add draw, update, and clean. Okay, so we're going to add draw, update, and clean. I'm going to click finish. And this is going to include draw, update, and clean in my files, right, in my class. Again, this is just the declaration. There's no details, no implementation, just the declaration here, right? So these are lifecycle methods that are inherited from display object, which in turn were inherited from game object. Okay, because remember, display object is a specialized form of game object that allows us to display and update our game object every frame. Cool. We also want to include some constructor functions. So constructors. We want to call this spaceship. Here's my constructor function. Oops. And we also want the destructor, or default destructor, spaceship. Okay, so this is destructor. Okay. And there's going to be sometimes a private area in our files. So any kind of private variables and stuff go in here. So this is the first step when it comes to you creating your own custom game object, and we're calling it Spaceship. Okay, Spaceship. There's an underline, and the underline says, hey, do you want to make this class final? And yeah, that's a good idea, because we're not going to inherit from Spaceship. All right, so we're not going to inherit from it. The other thing is, there's another underline, and it says, hey, by the way, do you want to generate definitions by declaration? And the answer is yes, I do. Again, this is all ReSharp or C++ helping me here. So I do want to, and it brings up this little dialog box that says, do you want to generate the definitions, or sorry, the implementation for all this stuff? And yeah, the answer is yes, I do. I'm going to click finish. So what it does is it declares the headers immediately inside of your spaceship.cpp. Again, this is assuming that you have ReSharp or C++. Worst case scenario, if you don't, or if you don't want to download it, you can always code this by hand. It's not a big deal. All right. So that is the first part. First part is making your .h, the .h being your interface, and .cpp is your implementation details for each of the methods that you've included. For those people coming in late, if you look up online and if you go to Blackboard, up on Blackboard, there is a couple things, right? I've got a Spaceship Texture that you can download that I'm going to use right now, as well as I've modified your project with the stuff that we talked about during lecture today. So I have a couple of gists that are here. One of them is alert between two vectors, which is just a little piece of code that I put up online. So if you wanted to copy this and include this little piece of code inside of your util.h, what you do is you take this part first as a header and you put this in util.h, and then you put this whole definition inside of util.cpp, which is inside of your core folder. Then you have the definition we talked about today in class and lecture. I did the same thing for random range, when a random range between two vectors. Sometimes we'll need to use that as well. Okay, cool. So lerp and a random range as an example. And then I have up online this repository that I'm working with called at George Brown College. So at github.com/George Brown College /GAME3001 Winter 2021 Lab 1B. And I'm going to make this the week or Lab 1 repo. So you can actually look at it and compare your stuff with my stuff. It's not for you to submit my stuff back to me. That's not the exercise here. It's just for you to be able to look at it and compare what I have compared to you have. So I'm going to go back to content inside of labs, Lab 1 Tom. And down in the bottom, I'm going to put a new link right now. So new link. And this is Lab 1 GitHub link. Okay, as an example of what I've done. If you follow along, again, labs are really super easy to get marks for. You follow along with the class, whether you watch the video afterwards or whether you follow along live with me. And then what you do is you submit it on the Friday at midnight. Okay. And the good thing is that the lab is being recorded, so you can follow along. Here's the recording for this week, and you have the recording from last week. So those are the two recordings that you have to get you set up, and then this week to do what we're doing. This week, like I said, I've talked about Git and GitHub, and I'm just now setting up my new game object. All right, let's get back to that. So we've made our spaceship game object here, and I've got on the back end this part. And what I want to do now is I want to load my spaceship, right? So that's the first thing I want to do. And one thing to note is I can add in a reference, an include to Texture Manager. So include. So I know I'm going to use texture manager.h. So there's my texture manager here. And in my spaceship, what I want to do here is I want to load it. Now, again, there's a couple of things you can do. You can include Texture Manager for the entire class, right? Including in your .h file, or you can only include Texture Manager in your .cpp. Sometimes it's safer to just put it in your CPP because we include H's but not CPPs when we, kind of make references to other files. But for now, let's leave it in the .h. So here in the Spaceship constructor, this is the constructor. We're going to load the texture we downloaded from the internet before. So we're going to say, hey, Texture Manager, I want you to go through the instance gateway, and I want you to load an object, again, with the path of /assets/textures/spaceship.png. That's the new thing I just downloaded and I shared with you up on Blackboard. And I want to call this thing a friendly name. I want to call this spaceship, and I want to store this spaceship inside of the texture map. So I can use this spaceship texture anytime I want. If I want to make 10 more spaceships, I can make 10 more spaceships, and they're going to point to the same texture map. Okay. So that's number one. First thing I'm going to do. Second thing I'm going to do is I want to get a size. So I'm going to say auto size, and that's going to equal to, hey, Texture Manager, I want you to go through the instance gateway, and I want you to get my texture size, right, from the texture that I just made called Spaceship. Okay, I don't know how big it is, but I want you to tell me how big it is. Size, then, if you hover over to size, because auto is kind of implicit kind of typing. So it creates a GLM vec2. That's what size is. And what I want to do is I want to set the size of my game object, so both width and height, to whatever the X and Y values are. So what I want to say is I want to set width to size.x, and I want to set height to size.y, and that takes care of the size in pixels for my object. All right, so that's the second thing I do. Now that I have the size as an example, we want to set some default values. So I want to get transform, and I want to say my position. I want to set up a new GLM vec2 object. Again, not wholly necessary, but I want to put it kind of in a spot. Normally, I try and put my objects kind of in the middle of the screen by default. So I'm going to say something like 400 by 300. Okay, I also want to get a rigid body. We also have a rigid body object. And the rigid body, I want to set the velocity of my rigid body to a GLM vec2, and it's going to be 0.0f, 0.0f. I also want to do the same thing with my acceleration. So I don't want my object to have any acceleration or velocity at the beginning, right? So we'll just change this to acceleration. And that's also going to be 0.0f. So position, velocity, acceleration. Also, I can also want to tell or set up that I'm not colliding right now. So get rigid body, and I go, is colliding is equal to false. So I said, so these are the things that I would start off with. I also want to set the type. So what I've set up here for you guys is a bunch of game object types. And if you look at the enumeration folder, the enums, there is a game object type.h enumeration, and I have none, ship, target, player, and so on. Let's make a new one. We'll call it, the very first one after none will be spaceship. Spaceship. So what this does is it sets up a way of us kind of naming our object, as an example, when we, kind of calculate collisions or figure out if there's a collision or not. So now that I've set up the enumeration for spaceship, which is the brand new object we're making, spaceship, then I can set the type. I can set type to spaceship, all right? And that is kind of my, set up all of my stuff here, if that makes sense. So again, what I want you guys to think about here, as an example, is just add these people in. What I want you to think about here is that I have initialized my spaceship in the way that it's done. Okay, guys, I started at 3, not at 4, so I'm a little bit ahead of you. If you want to, I don't know why I thought about what are we doing right now? I'm actually doing the lab. I'm going through the lab details. If you want to get, this lab, is the lab already started? It is. If you go up online and if you look at a couple things that I've put up for you guys, for people who are coming in late, one of them is, on time. One of them is, if you look at lab 1 GitHub link, if you start from there, please, I would ask you that you download your lab 1 and start from there, right? And then what this will do is will set you up with all the things that I've talked about so far. Offline, what I've done is I've talked about things like Git and GitHub, and a bunch of other stuff. And now what I'm doing is I'm reviewing what it would be like to set up a game object for the first time. And that's what I'm doing. I'm making a custom game object here. Okay. It says 4 for me too. I just started early, 3 o'clock. All right. I was wondering what was wrong. I was like, wait, how is it that I'm running so late? And then, of course, it's because we started at 4, not 3. Right. I don't know what possessed me to start at 3. I thought it was 3, but it's okay. It's a good thing. You guys got more content now, and you're going to have another, 2 hours of content here that compared to what we had. But not to worry. What I've done is I've gone ahead and all I've done right now is set up a GitHub repo. I've also set up a brand new object. I wanted to show it to you. I downloaded a brand new spaceship. So I got a new texture called Spaceship.png that I downloaded and modified from the first class. So it kind of looks like this. It's pretty ugly. It's not the most beautiful ship in the world that I downloaded from the internet. And I put this ship for you guys up on Blackboard. So if you actually go up on Blackboard and look at your spaceship texture right here, this is where you can download it and include it in your files. Okay. So I'm continuing with this. So what I've done so far as a review for people who are just coming in, I've created a brand new game object under the game objects filter. Again, the game object has two parts: the .h file, which is a spaceship.h, this part, which is just your declaration, and the spaceship.cpp, which is your definitions. Okay, that's what I've done here. All right, so and I'm going to take a short break in about 10 minutes, and I'll get you guys caught up, and then we'll continue with the next part. Okay. So spaceship.h has all this stuff, right? What I've done here is I've included a constructor as well as, yes, you can if you want to. So this is the, again, spaceship.h that's on inside of your game objects filter. That's where I've put it. Again, when you put your game object filter, if I select something, like I said before to the people that came in earlier, is you want to click add and you want to click new item, right, as an example, and you definitely want to target the source folder inside of your main folder, not the template folder. If you target the template folder, it won't work properly for it. Okay. All right, fantastic. So I've made again this part. This is the first part, and now I'm using the texture manager to load my spaceship here, and that's what this part is. So I've loaded my spaceship. My destructor can be default for now, so let's change it to my default destructor, right? And the last thing I want to do before we take a short break is the draw function. So how does this look? So typically we have draw, update, and clean as our lifecycle functions, and the draw function will get called as well as the update every frame for the most part. So what we want to do with the draw function is use the texture manager draw method to do it. And the way we would do that is, well, there's two parts. The one thing we want to do, first of all, is let's take a look at the texture manager draw function. So texture manager, I want you to go through the instance and I want you to draw. And draw requires the following. It requires an ID, which is a string. So it requires the name of the thing that I'm drawing, which is spaceship. X and Y coordinates. Okay. So I could put in something like get transform and then position.x and get transform position.y. But that's the X and Y coordinates that I have there in the signature. I'm just going to go to the next line so we can see it all in one thing. And then the next part is the angle, which is 0. So there's no angle. So my object isn't rotated in any way. And then what I want to do is my alpha transparency. My alpha transparency is going to be 255, which is fully on. And then followed by is it centered or not, which it's true. And I can leave the is it flipped or not off. I can say that it's not flipped. So we can just leave it like this. And that would be sufficient right there to satisfy my drawing requirements. But this is kind of ugly, and I want to think about another way to make this a little nicer. Okay, first of all, before we continue, I'm going to, so again, this is just me doing your homework from last week, which was, and I wanted to show of hands for people who maybe didn't do it. Did anyone have a chance to make their own custom game objects from last week? I asked you guys to do that, and I said, make a game object, you know, of your own. Did anyone have a chance to do that from last week? I know we're a little early, and I've recorded for about 55 minutes right now already, and I kind of did, before this, I did kind of Git and GitHub, and I went through all the details of that, and I'm going to go back and talk about all the other stuff and describe the game object that I've created here. So did anyone have a chance to do it successfully? Check marks if you did it, X if you didn't, or if you forgot. Anybody? Yay, I got one person who did it. So maybe yours went a little differently than mine. Okay, Jacob says X, and Jacob, maybe you have a problem. Well, I want to talk about that with you guys during the little bit of a break we're going to take in about 5 minutes. I'm taking a break, and then I'll talk to you guys offline, and then I'll get you guys caught up with everything that I've done so far. And as soon as you guys are caught up with me, then we'll continue the lab. All right, so you'll have all this extra stuff that I'm giving you. All right. So let's continue in here and talk about this. So not many people did the exercise that I gave you a chance to do last week. And I know why, because the framework is new for you and you're learning about it. You're trying to figure things out. You're trying to figure out how things work, okay? And it's okay to fail and not be able to make it, as an example. But what I've done so far for people who are just coming in is I've created a new game object called Spaceship. Here's my Spaceship. There's two parts to it. One part is the .h and the other part is the .cpp. I'm going to share this with you guys on GitHub in a second. So bear with me while I do this. All right, so let's run this thing and see if I get any errors. So by default, I shouldn't get any errors right now. And again, guys, don't panic if you're coming in. You're not coming in late. I started early because I wanted to talk about Git and GitHub for a bit of time and start setting up some stuff that I gave you to do last week. The little challenge that I gave you to do, which was create a game object of your own. And by default, you can see I have no errors right now. I have no errors. And what I'm seeing right now is my ship is okay. It's not erroring out so far. I didn't break anything when I put this together. Let's attach my ship as an example to my files, and we'll start from there. So this will be our starter for today, right? And I'll explain what I did. Okay, so how do I start this off? I'm gonna go to my scenes, and I'm gonna go to my playscene.h. In my playscene.h, I have several things here that I'm not using anymore, right? Let's take a look. So what I want to do is I want to get rid of pretty much my player facing, my player, my plane sprite. I think I would need to get rid of those things, right? As well as my back button, my next button, and my instructions label. So we're getting rid of all this stuff. That's in my playscene.h. And it asked me to clean things up, which I will. So if you notice up here, I'm just going to clean this up here. I'm going to, one thing that ReSharper allows me to do is remove all unused include directives and files. So it cleans this up. All right, again, for those people who are just coming in, I've been recording for about an hour beforehand just to get you going with Git and GitHub. So I recorded a bit about Git and GitHub. I'm going to stop in a second and get you guys caught up. Bear with me while I'm just finishing up this part. And I'm going into my playscene.h right now. And inside my playscene.cpp, I'm going to have a pile of errors. A pile of them, like this. Why? A lot of those things that I had before are being requested, and I don't have them anymore. So I'm going to get rid of all this event handling stuff inside my events handler area, this handle events method. I get rid of all those things. And I'm also going to just clean up the other part, which is all the stuff in start. So this is all the stuff that I put in start. I'm going to clean all this up right now, get rid of it all. And that should take away all my errors. And guys, for those people who are coming in, please don't panic. Just started early, and I'm going to talk about what I did in a bit. So under my playscene.h, here's my playscene.h. If you notice, I want to add in a new item, the one I just made. So I'm going to say that I have a new thing called Spaceship. Spaceship pointer, that's what I made. It asked me, do I want to include Spaceship? Yes, I do. And I'm going to call this m_p Spaceship. This is what I've asked you guys to do last week. I asked you guys to create a game object of your own, and I'm just doing it now for you guys in real time. Okay? So there's my Spaceship. And what I need to do now is I need to instantiate an object of type spaceship inside of my placing.cpp, which I'm going to do in the start method. So I'm going to say m_p spaceship is equal to a new spaceship, and I'm also going to position it. So m_p spaceship. I'm going to say that get transform dot position is going to be equal to a new glm vec2 object, which I'm going to put at 100 100. Okay, and I'm going to add this spaceship to the scene by using add child. Yeah, bear with me, I did start early. I'll explain what I did in a second. So this satisfies the requirement of what I asked you guys to do last week. Okay, this thing right here, which is in my start menu. And then I'll share this on GitHub in a second with you guys. All right, so I'll have everything. So let's play. And if everything goes well, and if I didn't break something, then we should start in the play scene with the spaceship at 100 100, which is kind of in the top left corner. Legs up. And that's my ugly new spaceship. Yay! And that's my new game object that I made. So done. I'm going to put this up on GitHub now, and I'm going to go into Team Explorer. I set up GitHub earlier today here. I'm going to go into my home changes. So I'm going to do all my GitHub here within Visual Studio 2019. And if you notice here, there's all these unstaged changes. I'm going to stage them all. And I'm going to say something like added new game object spaceship. And that should take care of all the things that I did for you guys just now. I'm at staged. I'm going to go to home. I'm going to go to sync. And I'm going to go to push. And that should push everything up to GitHub. So for you guys, where you're going to start is, we're going to, yeah, I did change the texture, and we're going to make it move in a second. Where I want you to get this starter is, if you go up on Blackboard for you guys, please start with inside of labs, inside of lab 1 Tom. If you scroll down at the very bottom, there's a lab 1 GitHub link. Please start there, and that'll give you everything I just did. So including the new, the 2 new links or methods that I put in from this morning's class, which are the lerp that lerps a vector, as well as a random range between vectors. And I gave you the code for these in 2 little gists. And gists are little online pieces of code that are stored up on GitHub. You can see that they actually look like this, a gist, right? And there's 2. There's the lerp between 2 vectors if you want to do it by yourself. And there's also a random vec between 2 vec2 objects. Okay, so that's the 2 little files you have there. But I put everything together as a starter in lab 1 GitHub link. So please go there and download that. And we're going to be using that for the next couple hours. Okay, I'm going to stop my YouTube recording now. I've recorded a couple things. One thing that I wanted to do, Ethan, what can't you find? Up on Blackboard? If you go to, the GitHubs, yes. If you go to, on Blackboard, if you go to labs, you find labs, there's a labs link on the left. And then if you go into lab 1 Tom, and if you scroll all the way down, you'll see the lab 1B, or that you'll be starting for this one, okay? All right, so I'm going to stop recording on YouTube now, and I'm going to explain what I've done here for you guys as a starter, so you guys can get going with your lab before we get going. So I'm going to stop recording on YouTube, and I'll be back with the next piece, which will be part 3.